To our today's lecture. Today, we'll take a look at chemistry. And our topic for today is separation of mixtures and purification of chemical substances. Separation of mixtures and purification of chemical substances. Under this topic, the first subtopic we look at is pure and impure substances. Pure and impure substances. So when a substance is said to is pure, a substance is said to be pure if there is no other substance in combination with that substance. For example, now something like sodium chloride. Sodium chloride. This substance known as sodium chloride is pure because there is no other substance with another chemical formula or compound is combined with. So it's just pure on its own. There is no other combination with any other thing. Something like sodium. Sodium as an element is pure because even though it does not exist as pure as pure substance in nature, because it is very very reactive, it does not exist as pure. It must be combined with other substances. But sodium like this, if when extracted, when purified, is pure on its own. So when you say that a substance is purified, it means that any other substance that is combined with is removed. And a pure substance maintains its boiling point and its melting point. Its boiling. But an impure substance has a lot of constituents mixed together, not chemically bonded. An impure substance has constituents but that are not chemically bonded. So an impure substance can as well be taken as what? Mixture. And the boiling point and melting point of an impure substance is not sharp. The boiling point is not sharp. The melting point is not sharp. It's a range. It's not a point. It's a range. It starts melting at a point and stop melting at another point. It starts boiling at a point and stop boiling. It's not sharp. It's not at a point. It's not a point. It's a range. So I am actually doing further distinguishing pure substance and impure substance because that is the main point in this distinguishing between the two of them. I've given two differences now. Basically, pure substances. Examples: you have compound. A compound is a pure substance. An element is a pure substance. When on its own is a pure substance. But mixture is not pure. A mixture is not a pure substance. It has other constituents that are not chemically bonded. And for a pure substance, for example, now water. Water is a pure substance. That's why if water has any other inside, any other constituent, it is taken as what? They are taken as what? Impurities. So when they say they want to purify water, that they are not touching the chemical bonds in the water. No, they are just removing other things that made it a mixture. But once you remove all those things, remove them using separation techniques, water will remain pure. That means when you say that the water is now pure, that means the water, what is there is only water. There is no other constituents. So if what you have is only water without any other constituents, the boiling point is 100 degrees Celsius. But if there is an impurity, if there are impurities there, the boiling point will change. The boiling point will do what? Elevate. Will be elevated. There will be an increase in the boiling point. Not just water, generally what? Liquids. The boiling point of liquids increase above their normal boiling point if there is what? Impurity. So this is also forms a criteria for test of purity of liquids. So if you have a liquid of known boiling point, if you want to know if that liquid is pure, check the boiling point. If the boiling point, let's say you have liquid A, inside you are told that what is inside this jar is liquid A. And from literature, you know the boiling point of liquid A. Now, if you want to check whether A is pure, boil it. If A is pure, it will boil at the standard boiling point of A. But if it has impurity, the boiling point will increase. The temperature will increase above its boiling point before it will start boiling. If that happens, is an indication that A has what? Impurities. Is a mixture, no longer is not a pure substance. But basically, compounds and elements are regarded as what? Pure substances, while mixtures are regarded as what? Impure substances. Now, for impure substances, for solids now, for solids, if the substance in question is solid, the melting point will not, if it's pure, the melting point will be sharp and it will melt at the standard known melting point as stated in the literature. But if you have impurities in that mixed with the solid in question, then the melting point, it will melt at a temperature lower than its melting point. So you can also use it as a criteria to test purity of what? Solid substances. To test the purity of what? Solid substances. So if a solid substance B, you want to test if it is pure, melt it. Of course, if you are told that B, you should know the melting point of B as stated in the literature. Now, if you melt it and it melts at a temperature lower than its melting point, then B has other impurities. But if it melts at that temperature, known as the known temperature, at temperature taken at its melting point, if it melts at that point, that means B is actually what? Pure. There is no impurity in B. So with this now, I've explained pure substance and impure substances. Give example. Then the distinguish between pure and impure substance. Then I also talked about boiling point and melting point as criteria for what? Test of purity of what? Substances. As a criteria for what? test of purity of what? Substances. Good. So we've treated pure and impure substance. We have also treated the boiling point and melting point as what? Criteria for what? Test for what? Purity of what? Substances. Now the next topic I want us to talk about. Under this topic we've discussed pure and impure substances. We've discussed boiling and melting points with respect to the criteria for test of purity of one substances. Now I want us to discuss elements. Compounds and what? Mixtures. So here now I will now discuss these things in detail. Actually, elements, compounds, and mixtures, they are what? They are the three these are the what? Three classes of what? Matter. Elements, compound, mixtures. Matter is classified into three: elements, compound, mixtures. We have three classes of matter. We have three states of matter: solid, liquid, and gas. Actually, there are four: plasma, solid, liquid, gas, and plasma. But we limit ourselves at solid, liquid, and gas. Now, we also have three components of what? Matters. They are what? Atoms, ions, and atoms, ion molecule, and what? Ions. We'll see discuss all those ones, but our focus is on what? These three, which are the what? The three classes of what? Matter. Which are the what? The three classes of matter. So let's start with elements. What is an element? Sorry, our reference book for today is New School Chemistry for Senior Secondary Schools, 2016 edition by Oseyo Ababio, as revised by LES Akanisi and Herbert Igwe. So this is our reference book for today. So let's go back to elements. What are elements? An element is a substance which cannot be split into simpler units by ordinary what? Chemical process. So ordinary chemical process cannot split an element. So when you get to a point where the substance cannot be splitted into simpler element by simpler units by ordinary physical processes or chemical processes. That's the word, an element. So an element is actually very small that it cannot be what? It cannot be split further again by ordinary chemical what? Processes. So there are hundreds of elements, and these elements, there are many of them. They are fully discussed in the periodic table. So when we discuss the topic periodic table, then I'll come back to this. But basically, elements, of course, example of elements, we have sodium, abundant sodium, oxygen, carbon, there are many of them. But there are first 20 what? Elements. We have the first 20 what? Elements. Around 109 in numbers. Known elements are around 109 in numbers. And elements are normally represented by what? Symbols. And these symbols most times is their first initial. Although some don't use their first what initials, especially when that initial has been used for. The elements are arranged according to their atomic numbers in the periodic table. So if the elements, basically all the elements normally start with their what? The first letter. The first letter of their name are normally used as what? As the symbol. But when on coming down, when they realize that some have the same words, initial word letter, so they have to change. Some add extra letter to distinguish it from the one that came before it. And also, sometimes Latin names of these elements are also used. Something like gold. Gold, instead of using G for gold, you see something like this. AU. Silver. Instead of using K for silver, it's something like this. It's from their words, Latin names. It's from their words, Latin names. We'll see discuss this in detail, but just let's stop it at this level. It's from their words, Latin names. Okay. So elements are actually grouped into the following. We have the metals, non-metals, and the what? Metalloids or semi-metal. So we have metals, non-metals, we have metals, non-metals, and the same metalloids. Let me use metalloids. Metals, non-metals, and metalloids. These metalloids are also called what? Semi-metals. These metalloids are also called semi-metals. So when we go to the periodic table or start going into atom fully, we'll explain these elements, especially when we go to periodic table. Yes, and we also go to chemical equation and balance of chemical equation. We'll talk more on that. Let's keep it at this level. That an element is a substance that cannot be split into simpler units through using ordinary chemical processes. Okay, so now having looked at elements, let us now, an element, as I said before now, an element is a pure substance. Element is a pure substance. That's why you hear to purify to purify the element, especially when it is extracted. If it's extracted, maybe from ore, as case may be, you find that it has other impurities. So it's because naturally on its own, an element is pure. The element is a pure substance. That's why we say, let us purify it. It's something that is already pure. It's pure on its own that we purify. It's only something that is pure that is contaminated. So if it's pure on its own, then if it is a pure substance, then sometimes if it has other mixtures, as I said before now, it can be now it can now be what? Be purified. Okay. Now, another thing I want us to look at is, but before we do that, I want us to look at compound, but let us see one or two things more on what? Elements. So remember I said that elements are grouped into three. We have metals, we have non-metals, and we have semi-metals or metalloids. Metals, non-metals, semi-metals, and metalloids. Now what actually happens? Let me just say what of it is about metal, then we move on. What are even metal? Actually, metals are the ones that actually ionize. Of course, you know what ionization is. Ionization, ionization, there's what? Transfer of what? Electron. It's either the substance gains electron or loses electron. But those that ionize by losing electron, they are known as what? Metals. While those that ionize by gaining electrons are known as what? Non-metals. Examples of metals, you have here calcium, magnesium, sodium. These ones are metals. Examples of non-metals, you have here oxygen, chlorine, you know, sulfur. This one, they gain what? Electrons. They gain what? Electron. Even nitrogen, they gain what? Electron. Is there any difference between metals and non-metals? Metals and non-metals can be distinguished based on their physical properties and what? Their chemical properties. Based on the physical properties, that is the physical properties, of course, metals are what? Ductile. Metals are what? Ductile. And metals are what? Malleable. Metals are malleable. But non-metals are not malleable. They are not ductile. They are not ductile. Then metals are lustrous. That's why you get things like metallic luster. They are lustrous, but non-metals are not lustrous. Of course, metals are good conductors of electricity and heat. They conduct electricity and they conduct, but non-metals don't have the capacity to do that. So metals usually have relatively high density than non-metals, but non-metals have relatively low density. So these are the few examples, a few differences between metals and what? Non-metals. Then in terms of tensile strength, metals have high tensile strength. In terms of tensile strength, metals have high tensile strength. But non-metals, they don't have, they don't have this, their tensile strength is slow. That's why they are brittle. They can easily break up. But metals, they have tensile strength. But non-metals can easily be broken up. Can easily, they are brittle. Some are soft, unlike what? Metals. Okay, is there any difference between metals and non-metals in terms of their chemical properties? Yes. In terms of their chemical properties, metals, when metals react with oxygen, the oxide they form are basic oxide. You're welcome. When metals react with oxygen, they form basic oxide. But when non-metals react with oxygen, they form acidic oxide. Something like this now. If we have, this is carbon, this is oxygen. If they react, they form, depending on, they can form. To form, the one that is acidic is more of CO2. To form CO2, there will be excess of what? This anyway. In excess of this, they will form CO2. Now, if they form CO2, this CO2 is acidic. This oxide is very acidic. It can easily form acid. That's what we mean by acidic oxide. Non-metal oxygen, they form acidic oxide. But when metals react, they form basic oxide. If magnesium react with oxygen, they form magnesium oxide. They form what? Magnesium what? Oxide. This oxide is basic. It's basic. It's even carbon. Sorry, calcium. If calcium react with oxygen, calcium form what? Calcium oxide. This is what? A basic what? Oxide. It's a basic oxide. It can easily form what? Base. It can easily form what? Base. The same thing with sodium. Sodium reacts with oxygen, so it will form a basic oxide. So generally metals, when they react with oxygen, they form basic oxide. But when non-metals react with oxygen, they form acidic oxide. They form acidic oxide. So basically, generally metals are, you're welcome. We actually looking at this topic, separation of mixtures and purification of what? Chemical substances. Chemical substances. So we've treated under the subtopic pure and pure, according to the JAM syllabus, okay? Pure and impure substances. We compare the two of them, the difference between the pure and impure substances. Then we also talk about boiling and melting points as criteria for what? For what? Testing the purity of what? Substances. So then it's elements. Here now we talk about in element, compound, and what? Mixtures. And these are the what? The three classes of what? Matters. Three classes of matters. Discuss. We are in elements now. So they're under element. Maybe after you can watch the pre-recorded lecture for these two. So we don't start going back. So here elements, we said elements are classified, elements are grouped into three. We have metals, we have non-metals, then we have what? Metalloids, okay? Or semi-metal. So we are not talking about metals now. We are distinguishing between metals in terms of their physical properties. Now we are talking about their what? Reactivity, their chemical what? Properties, how they differ from each other. All together? Good. You're welcome. So let's continue. So generally, metals are generally reducing agents. You can put it down. Metals are what? Generally what? Reducing agents. Do you know why they are reducing agents? Because they are tend to do what? Lose electron. They are tend to ionize to lose electron. If you go over to the topic reduction and oxidation, if you find out that reduction is actually reduction can be defined as what? As what? You know, it can be defined in different ways. The same thing with what? Oxidation. In terms of oxygen, or the oxidation is what? Addition of what? Oxygen, right? What of reduction in terms of oxygen? Loss of oxygen. Yeah, what of electron? In terms of electron, oxidation is what? Yes, it's just what about classify? Is it to get electron or to lose electron? Oxidation. Does substance oxidize by losing electron? Okay, now let me explain. Now, metals are taken as what? Reducing agents. Metals lose electron. Metals lose what? Electron. Like now, if I am the metal now, and you are the non-metal, right? I'll lose electron. I'll give you electron. And if you accept the electron, I have reduced you. Am I completing? Am I completing? If I give you electron, if I lose electron, and you accept that electron, I have reduced you. Then, but you have oxidized me. That is in terms of the electron transfer. Oxidation is loss of electron. Me metal, I lose electron to you and get oxidized. But you that gave the electron, you get what? Reduced. So me, the metal that gave you the electron, I'm the reducing agent because I have reduced you. Why you, the non-metal that take electron from me, you have oxidized me. You are the oxidizing agent. So in terms of electron transfer, oxidation is the loss of what? Electron. Because you made me to lose the electron. While reduction is the gain of what? Electron. You if you gain electron, you are oxidized. Sorry, if you get electron, you are reduced. So in terms of electron transfer, oxidation is loss of what? Electron. While reduction is the gain of what? Electron. Non-metals gain electron from metals, so they are reduced. While metal give electron to non-metals. Therefore, metal reduces non-metal, while non-metals oxidizes what? Metals. Am I complete now? So that's why you're saying here that metals are reducing agents because they have the tendency to do what? Use electron. While non-metals are oxidizing agents, but they have the tendency to do what? Accept what? Electron. And when non-metals lose electron, they form cations. When metals lose, have you ever seen a class? Have you ever PCC your radio before or your phone? And so to tell you what component you saw there. So good. What happened in motherboard? Huh? You don't know. You don't know. Okay, let not take me far. Silicon is a metalloid, okay? Silicon is an example of a metalloid. Can you think where you can see silicon in nature? Good! Sand. I like that. Sand. What is sand a double word? We'll see treat it, don't worry. I like that. So silicon is a what? It's a metalloid. Put it down. That's an example of what? Metalloid. There are many of them. When we treat periodic table now, if you go to the center of periodic table, if you go to the center of periodic table, if you leave the at the center now, like this, if you leave the first row, those who go down, most of them are what? In between, most of them are what? Metalloid. Most of them are what? In fact, most of the elements in the transition most of them are what? Metalloids. Semi-metals. Except those that the first row. We will still treat periodic table, then you understand it better. Most of their names are not that common. But we see how those that are still common. Things like mercury, things like gold. Yes. You don't know? Is it a metal? Okay, gold is a metal. Is it a metal? I'm confused. What of mercury? Say that no, it's not a metal. Don't mind me. These are what? They are what? They are metal. What of mercury? Is mercury a metal? Liquid. How many liquid metals do we have? Which is what? Mercury, gold. Can you see what I'm writing? Check there. Clearly. Okay. So mercury, gold, Silver, are they metal or same metal? Which one? Or metalloid? Immediately I say metalloid, you say writing it on without even taking it twice. Please be careful, oh, please. They are what? They are what? Good. They are what? Metals. What of platinum? Is platinum a metal? Platinum. Eh? Is it a metal? Platinum is it a metal? Okay. Oh. Check well. Oh. Check well. Platinum is it a metal? Dissolve. Platinum dissolves. Are you sure? Oh. Platinum is a metalloid. Okay? Put it down. It's not a metal. But it's not a metal. I know they use saturated, but it's not a metal. It's a metalloid. It's a semi-metal. There are many of them. Palladium. There are many of them. Those ones are not that common. The ones that are common are silicon, platinum. They are common. So let us go to what we are. Your question was what took me there. Now, we are talking about what? We are done with element. Let's go over to compound. And I said that is element a key substance or an impure substance? Good, it's a key substance. So compound, what do you understand by the term compound? Okay. To be what? Combination of one or two elements to give the desired bonded. Because of that, they can easily be what? Separated using what? Physical means. It doesn't even need much stress. By the time we go over to separation techniques, you will understand it better. Does it make sense? Good. So, if you go to that God, if you go to this gutter now and pack and take the water there, that water in that water has a lot of things inside it. It's a mixture. But if you want to now separate and get pure water from it, I know that you can get pure water from it. By what? Distillation, hope you know. Yes, you can get pure water from it. Get water and mix water and salt. And the salt dissolve in water. It's a mixture. Hope you know. And you can separate them and still get your water. Are you aware? So this is a mixture. This is what we mean by what? Mixture. Sorry. Any question? Any question? Good. So there are many examples. There are many examples we can use to describe what mixture is. So how do you think we can distinguish between elements, compound, and mixtures? Distinguish between elements, compound, and mixtures. Elements. Okay. Combine, okay. 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 Then, in terms of purity, Element is pure, it's a pure substance. Compound is a pure substance, but mixture is not a pure substance. Okay, good. I like that. I like that. Okay. The next topic is chemical and physical. Any question? Okay. Huh? So what? You do what? You do what? Wow. How will you do it now? There's no time here. Sorry about that. No one will soon be dismissed now. D. Let's look at chemical and what? Physical changes. Or physical and chemical changes. Anyone. So that's what. Alright, so chemical and physical changes. Matter undergo some changes. Remember, matter, law of conservation of matter. Matter change from one form to what? Another. Change from one form to what? Another. Matter move from one of its states to our what? Another. It can move from solid to liquid, from liquid to gas, and vice versa. So because of that, now look at what we take a look at what? Physical and chemical changes. What are physical changes? What are physical changes? Physical changes are those changes that are easily what? Reversed. And no new substance is what? Formed. Physical changes are those changes that are easily what? Reversible. And no new substance is formed. No new substance is formed in physical changes. No new substance is formed in physical change. For example, now, you know your candle. Get the candlestick, put it in a container, and light it, allow it to burn. Candle will burn. If you look at the base of the container, you will see the candle liquid. And as far as there is heat there, that candle liquid will remain liquid. So it has moved from solid, which is the stick, to the liquid. That's a physical change. Now, if you bring a temperature, if the heat stops, if the heat is removed, that liquid, that molten form of the candle, that liquid form will solidify. It will go back to what? Solid what? State. So this is an example of what? Physical change. No new substance is formed. It's still, the substance is still that candle. But it just the form, the state is changed. So that what happened in what? Physical what? Change. Physical changes. Get water and salt, mix them. They form a mixture, they form a solution. This solution is still inside that solution, you still have your salt impact, water impact. No new substance is formed. It's just a salt solution. And you can recover both the salt and the water. So it's a physical what? Change. It's a physical what? Change. What of chemical changes? Chemical change are those changes that are not easily reversible. They are not easily reversible, and the new substances are formed. So new substance is formed in what? Chemical change. Example of chemical change is burning of your firewood. So if you burn your firewood, something that came as wood, if you burn it, it will form charcoal, and that charcoal is not, and that charcoal can never go back to the wood again. That charcoal can never go back to the wood again. So no matter what you do to that charcoal, it can never come back to wood again. So it's a chemical change, because the charcoal is a entirely new product from the wood. There are many of them. When a substance decays, it moves from that form and goes into a different, entirely new thing, a new product that can never reverse again to form the initial substance. Even iron,